All right, so this is lecture 14. Before we begin, I had an announcement. Exam 2 is coming up in 2 weeks, of course, so I don't want to kind of scare people here. We still have 2 weeks, and most likely I'll release some practice material next week. And then on the day of the exam, as usual, we'll have like a review session. So you'll have plenty of time, but just like a gentle reminder that exam 2 is coming up. The other thing, homework 4 is due tonight and homework 5 will release tonight. And again, it will be due in a week's time. All right, so those are the announcements that I had. And coming back to our lecture, today's lecture is shorter as compared to other lectures because we're just like talking about this generic aspect of coding, which is problem solving and design. This is part 1. We have like another part to it, of course. And because we haven't covered too many like data structures as such, it's just the list and 4 tuples. So we will try to focus on lists and a little bit of tuples on how to solve like a given problem. And we look at like 2 different perspectives of the same problem and how to solve it, how to approach such problems. We are not introducing anything new in today's lecture, and this one like has just like one problem that we focus on. The other thing is there is no lecture exercise with this one because that question has come up many times. So there is no lecture exercise for lecture 14, which is good. That gives you some like time, at least for one lecture. And with lecture 15, we begin with sets and dictionaries, which is like another like data structure that is important, that's essential, and we'll see why it's so important and how it is different from lists. So that we begin next week, but today there is no lecture exercise with this lecture. All right, so having said that, let's begin. And as usual, whenever you have questions, just type in the chat window and I'll try to come back and answer those. Okay, so this is like the first of our lectures that's dedicated only to problem solving and design. And we are not talking about any new programming construct. We're not talking about any new technique. We know everything, and now we will try to apply that. And we've tried to like outline this problem solving and design process somewhat here, that like design comprises of these things, and then what should we do after that, and how to like approach a problem, how to solve a problem in terms of like designing everything. And in general, whenever you read a problem, you usually are given like on homeworks and exams, you're usually given like work with this data structure, or the data comes in a list, or data comes in this format and do this with this, right? Sometimes it's not. And then the choice of the data structure or the choice of the container which you'll be using to save your data comes to you. So it is up to you how you're going to like select a particular data structure and why. And of course, like, as I said, we don't have a lot of choice at this point, and maybe we'll understand this point better when we have done sets and dictionaries and other data structures, because then you can like literally go and compare why is one better than the other. And in some situations, why is a list better than a dictionary? And in other cases, why a dictionary is better than a list. So at this point, this is just like a statement, choice of data container, data structure. For now, we will just like focus on lists. Maybe some tuples will come in, but then you know the major difference between tuples and lists. Tuples cannot be updated, and so mostly when we are saving data in our code, it's lists because of the flexibility they offer. And the second thing in my design part is the choice of your algorithm, which is like the selection of the steps that you will follow in order to solve that problem, right? Once you have this sketch, this design, the step 1 of design, then only you should move on to implementation and then testing and then debugging. Excuse me. So let's begin with like the lecture notes talk about finding the mode. I'm going to jump to that in a bit. Before that, I wanted to look at even like a more simpler problem to understand what this design essentially is talking about. So I have this very simple problem which everybody can, I'm very sure which everybody can solve in this class. I just wanted to go over the process of solving a problem, which is why I selected a very simple problem. And so the problem is asking us to find all pair of indices for those elements whose difference is k. Return a list of tuples for each pair. So you're given a list, and then we are asking you to find those indices such that their difference is some number k. And most likely, let's assume that that number is a user input, right? Of course, these are the questions that you should be asking if we are asking you to write the solution to this problem. But let's assume k is given as user input, right? Input, and then maybe I can say, please enter the number k. All right. So let's begin like kind of brainstorming as to what should be the solution approach. Now, the first thing that comes to our mind here is that this is already telling us return a list of tuples, right? And then the input is already given to us, which is like another list, right? And let me write these things down because this will help. Okay, so in terms of the solution approach, like step one, in terms of the data container, I'm already like given lists as input. So there isn't much like I would say choice here, because I know that, yeah, the list is already an input. And then the output is also going to be a list of tuples. Okay, something weird is happening to the pen. Anyways, so what are we going to begin with, like in terms of like the solution now? Now, in terms of the solution, I'm given a list. All I have to do is create this list of tuples, which means my step one is going to be to create an empty list, right? Because I need this list. So create an empty list. That's my step one. Why? Because I'm like the problem is asking me to create a list. So I'm going to create an empty list, right? Now, next, what should be like step two? Because now I have to go and scan through this given list, which is my input, and then check something, right? So what I can do is I have to go and scan through the list. So that's my step two. Scan through the list and find absolute difference between every pair, right? So that should be my step number two. Go and scan through the list, which means like go and iterate over the list, find absolute difference between every pair. Now, the third step would be, of course, like you can kind of make an outline of these steps. So match with K, right? Match this difference with K. Match this difference with K, right? And when a match is found, then, so whenever a match is found, save in whatever your list was. Create this empty list, let's say was, I don't know, X. So save in X, like in the form of a tuple. And then continue this until we have exhausted the list, or maybe like keep doing that until you're exhausted, or you have like scanned through every element of the list, right? So this is my design element where I've figured that I need this particular data structure, which is my list, and some kind of a methodology of what needs to be done. And then once I have these steps listed out, then only I should move to implementation. So this is my design step. This is absolutely essential. Like until and unless we have some kind of a structure of our program, we shouldn't be like really implementing it. So now coming to the implementation, when the implementation part comes in, you can actually pick things from here. So create an empty list, you know how to do this, right? So just like create an empty list, scan through the list and find absolute difference between every pair. What kind of a construct do you think we need for step number two? When you see this every pair, scan through every pair, what kind of excellent, Caesar? So you're right, we need a loop. And because we are trying to scan through the list and have like, yeah, it could be a for loop, Bhaskar, you're right. It could be a for loop. It could also be a while loop. It's up to you. The important point here is that maybe you need a nested loop, because essentially what you're trying to do is you're trying to compare two elements. And the way to do that is either like you figure some way of like not going outside that, or maybe a nested loop. So it's up to you, of course, how you would like to structure that. Loop is essential because I'm scanning every element. And then maybe it can be nested, maybe it cannot be nested, because like if I'm like restricting my loop to like the element one less than the last element, then maybe I can like keep getting every pair and matching it with K. Either ways, it's fine, whichever works better. Now, nested loop can create issues only when, and we'll see why later on in the course, not yet, but nested loops in general create issues when this list is, let's say this list has 1000 elements, right? So whichever you choose, like a single loop or a nested loop, will depend on your input, your choice of your data container. Because if this has 1000 elements and if we are using a dictionary, as you'll see going forward, then this is not a problem. But if you're using a list, this is a problem, because lists are like these sequential element, like sequential data structures where I have to go and access every element. So this might create an issue. But for now, we are fine either like whether you choose nested or you use like one loop. You're fine as long as you're able to accomplish this, like match the difference with K. And then whenever a match is found, just like do a dot append. So you know that this one is like a dot append to your X, right? And dot append that tuple, whatever that I and J is, if you are using a nested loop. Or if you're not using a nested loop, then it would be like I and I plus one, or whatever you're doing. But most likely it has to be a nested loop, because I have to compare every element with every other element. And that is possible with a nested loop. All right. So now once we have the design, we can go and like actually write the code, and it's totally up to us how we want to do it. Let me use a nested loop because, and let's say X is my original list, right? My empty list. And okay, what happened to this? All right. So for I in range len of L, just like we do for, and it's, if while loops are more convenient for you, just go ahead and do that, right? And for j in range, what do you think the range should be here, and why for the inside loop? Right, I'll just wait for somebody to. Okay, Lauren is saying I plus 1. Even if I do an I, right, and do not tell what exactly should be. So this is the stop by default if I'm just like providing 1. So this is like taking care of I plus 1, right? So this should be fine. And then let me create an empty variable where I'm just like comparing the difference. So all I'm doing is do an absolute between L sub j minus L sub I. And why am I doing an absolute? Because I just have to match the difference. Maybe like going back to the question as asking the person who has asked the question, or whether it's a problem on the homework, going and checking whether we require this, or is it like the actual difference only, right? So whether it's an absolute difference or an actual difference. And then if diff equals K, which is going to be my user input, then just like do X dot append, and it's a pretty straightforward problem. I wouldn't say it's a hard one. And then just like go and print X. All right, so the whole purpose of showing you this problem, although this is like a very simple one, is to show you the entire design process. And doesn't just like end here. Maybe another step would be to first execute it and like give very extreme values to this. Like what happens if somebody entered the number 0? What happens if like somebody entered a negative number here? Is my code handling that? Well, my code is not handling that, right? So things like these, like what happens. So there is like a few things missing in this code, right? What happens if K is 0? So those are extreme test cases. Or if K is negative, right? So we have to be careful about those things, because again, it depends on the problem. What exactly do we want out of this code? And definitely my code is not handling this part. And so go ahead and add like how to handle these cases, because these are extreme cases, and sometimes that is where your program is failing. So that is this thing, which is like talking about testing. And once you're testing, go and test with extreme values. What happens if like this list has all negative numbers, or if this list has all positive numbers? Like think of these extreme cases. And once you have those extreme cases, then go and test. And of course, like if you see that for one of the test cases, of course, like for in our code, it is going to fail for a lot of conditions. You can tell just by looking at it. So then go and debug. So debugging is not just like getting rid of syntax errors, but getting like taking care of these extreme test cases. You must have noticed like until now in homework 3, homework 4, it was the semantic errors that were like taking up most of your time. And so that's what this debugging is all about, the semantic errors. All right. So, and of course, this is not one way of like, this is not the way of doing this problem. There could be 10 other ways of doing this problem and more efficiently. So maybe this is like the brute force, like the most basic approach. Always begin with the most basic approach. There is nothing wrong with that. But then improve, right? Maybe I could have done better somewhere here, right? Maybe I could have skipped some things here and then like improving there. So this is like the first solution that you write is not always the best. And so improving that, thinking about what better, can you get rid of a few steps? Are there some redundant steps? All of that comes under this debugging. All right, so this was like a pretty simple example, but now let's move on to the actual example that's given in the lecture notes, which is like finding the mode. Mode means if you're given a list, you're trying to find the element that has the maximum number of occurrence. And I'm going to show you that. Let me first see the chat. Yeah, Caesar, your question is why range I? So what is I? I like is, let's say when I is 0, then this won't like do anything because this is the same element, right? But then range element goes 1 ahead. So that means when I is 0, this is going to take 1, right? So I'll have the difference between the element 0 and 1. Oops, what happened? Right, so then I'll have the difference between element 0 and 1. And then I'll have, because I will be 0 for the entire number of like iterations for the outer loop, I will be 0. And so J is going to take that, just that and come out. In the next iteration, when I is 1, then J is going to take all the values like 0 and then 1, and then 0 and 1, 2, right? So yeah, you can definitely solve. The question is, can you solve this using a while loop? Of course you can do it. Just go ahead and use while loops, right? It's a very simple problem. Like think about it. We are just like picking two elements. And going back to the question that Caesar asked, you can have like some different way of handling this here. You can still say for J in range length of L and have an if condition here where you're not taking the exact same elements, I and J. When I and J have the same value, then obviously that's going to be 0 and we don't want those cases. But if you have them, it's not hurting us. So you can have them, of course. So as I said, you can improve this here. Think of like, are we handling any redundant cases? If we are, just get rid of that. Yeah. All right, any other questions? Huey, your suggestion was go from I plus 1 up to length of L. Yes, as I said, you can definitely do that and see if we are capturing all the possible like pairs. If we are good. If we have like redundant cases, as I said, like repeating things, I don't think that's a good solution. So get rid of that. That's all we're trying to do here. Okay, so I think those are all the questions. Let's move on to this problem, which is finding the mode. So what is like mode, first of all, and we are going to look at two different variations of this problem, how to solve them. And the most important thing is it depends on how the data is provided to me, because a lot will depend on how I'm going to extract the data and then find the mode. And for those of you like confused, let me show you what mode is, first of all. This is like, yeah, as the like lecture notes are already telling us the value that occurs most often. So let's say you're given these numbers like 2, 6, 9, 2, 5, 6, 2, 1, right? So these are the set of values that are given to you, and the mode of this is 2. Why? Because 2 occurs like that has the highest frequency. So mode is nothing but the highest frequency from a given set of numbers. Now, the issue with the problem that we are looking at is that the set of numbers is not as straightforward as this example. So we are not like given a list of these numbers. first of all. What we are given is we are given a list of tuples. And those tuples have like no significance other than we have the data within them, like in pairs. So it adds like another level of difficulty. That's it, right? Because I have those elements within the tuples in that list. And so I need to get those elements out and find the mode. That's all that is there to this problem. So let's look at the data first, because that's my data container and that's how I'm going to approach the problem, right? Right. And okay, so let me show you the data first, then we'll come back here. And I just copied it from the lecture notes that we have. So here is the scores list. And as you can tell, like we have this data in the form of tuples. And thinking about this doesn't really have any significance as far as I remember, except that the data comes in this form. And what we are supposed to do is we are supposed to find um, like the element with the most that occurs the most number of times. Okay, sometimes this mode problem is easier when we are given like some kind of relationship between the number and the index. Like let's say they're sorted or they are in a certain order, or for example, this lecture notes talk about that. Is there a limited indexable range of values? So that's the first question that you should be like asking, because these are the variations that can happen in this problem, right? This is a very general problem, like, okay, go and find the mode. So then we have to think about, okay, what is given to us? Is there a limited indexable range of values, or the values are going to keep coming up and the user can enter them? Because then the problem becomes more difficult, right? And okay, examples that are consistent with this variation include like test scores or letters of the alphabet, because yes, there is this indexable range of values. Letters of the alphabet, we have 26 of them, right? Or like whatever is there in that, let's say there is a given set of letters from the alphabet. This is the only set of alphabets that can happen, right? These 26 only. But with numbers, it can, let's say, go on and on. With test scores, again, we have this like limited range of values. Most likely it's not above 100, right? And then, as I said, examples not consistent will be like counting words, counting amino acids, because there could be like any combination of letters and words, similar to that in amino acids. So we have to take care of all that. And the other like question to ask is like, do we want to stop at mode, or do we want like how many times each value occurs? For instance, here, if I look closely, I can tell 2 is a mode for sure. So also, do I want to like report that 2 occurs 4 times, right? It occurs 4 times, right? 1, 2, 3, 4. Yeah. So do I have to report that it occurs 4 times or not? That's an important question. Or do I just have to like come up with the final mode? So that's another variation that can happen. And that's the question that we need to ask. And then do we want a histogram where values? So of course, this is not something that we've done in class, but think of this histogram as something that we want to like group together values and then maybe report them. So this is like telling us, do we want to group like every number? For example, like number 3 occurs 3 times, number 2 occurs 1 time, whatever, right? So do we want some kind of a grouping happening or not? And then there are multiple examples from real world that can take this variation. All right. So having said that, having like understood what the problem is, now what we are looking at is, let's say we are given a sequence of numbers that will be integers, right? And we will focus on this like test scores one. Of course, we can translate our code for floating points as well, but let's focus only on integers because that's something that we're looking at. That is our input, right? So let us begin thinking about, and we are looking at 2 different variations of this problem. So the very first variation that I'm looking at is that I'm given this data in this form. And by variation, I mean the solution approach, right? So there could be multiple ways of thinking about this. Now I'm given this data. How about I create a list of indexable values? And if I have like a matching range of like indexable values, then I can just like get the index and report that. All right, so what does that mean, right? Let me show you what that means before we start writing the code. Okay, So we know that we have like these numbers, and let's assume that the range of these values is like finite. And I can tell like the biggest number is 30, right? And maybe the smallest number is 0. So I have like this range of like 0 to 39. And this is not a list. Let me just get rid of that. 0 to 30, sorry, not 39. Right, so I need these like 30 spaces. And my idea is to create indexable values, meaning let me create a list that has like these 30 spaces. So what will happen then? Because like I have this range of 0 to 30, which is indexable, which is easy to create. If this was like 3000, then this solution will not work. The solution that I'm like thinking about, the very first type, I mean, the very first solution that I'm thinking about. If this was 3000, then this wouldn't work because it's not a good solution. But now because I just have like 30, then what I'm thinking is I'll create a list, an empty list of size 30, right? Once I have this, what I can do is I can keep updating it based on its index. So what I'll start doing is this I'll count as like the index for example, um, let's say there are how many zeros are there, because the index of like the position of this element is 0, right? So I'm going to count how many zeros are there. So for example, I have like 1 0, 2 0. So this should be updated to 2, right? And then this, the index of this is 1. So I'm going to count how many ones are there. And so let's say there are 1, 2, again, 2 ones. So I'm going to update that, right? And then the next, the index is 2. So go and count the how many elements are there, and so on until 30, right? And the index is mapping to the element and the value is mapping. And so let me write it down. Index is mapping to the element, and this value is mapping to the count. And then I can just like output that this is the max count, whatever the max is of this list. Why this is easy? Because let's say like my mode is, as I said, 2 and this is 4. And if I do a max on this list, then I can get the index of that, right? So the index of that is obviously 2. And so I know that the mode of this list is 2. All right. So let's actually go and implement it. Okay, so this is one solution. As I said, the like drawbacks of this solution are that I do not want a similar solution if I have like elements starting from, I don't know, if we had negative numbers, for example, then we cannot map, first thing. The second thing, if we had like huge sort of gaps in the range of values, then it's useless because you'll have like these huge range of values in my list that are empty. And then if like the highest value was not 30, but maybe, I don't know, 5,000 or something, right? So those are some of the limitations of this approach, but let's implement this approach. Okay, so what I'm going to do is I'm going to get what is the highest value in my list, right? And create a list of that size, because that's what I'm trying to do. So let me actually do this strategy where I just say high is scores, and then the way I'm going to access any element is two indices, because this is like a list of tuples, right? And so this is initialization. I'm saying the highest one is the first one, right? And then I'm going to loop through scores and get the highest one. That's all I'm doing here. So for score, for variable in scores. Now, if score 0, which I just got from here, right? If score 0 is greater than high, then go and update high with that, right? And do the same for score 1. If score 1 is greater than high, then do that. And let's print high and see if we're getting the right one or not, right? Otherwise, we'll have to change this. All right. So the highest number is 30. That's correct, right? The highest value, extracting the highest value from this. And based on that, I'm going to create this empty list of zeros, as I said, and then start updating it, right? So let me go and create that empty list first. And remember, we're starting to count from 0 and not from 1. And so I'll create like high plus 1. right? List of size high plus 1. So L equals high plus 1. And the way you can create a list of all zeros is like one way, I would say, is just like multiply it by a list, and then we'll see if we are getting the correct list or not. All right, so we have it here, all zeros. Now our job is not that hard, because what I'm going to do is I'm going to go into scores, which is my original list. And for instance, I'll pick this element, right? This 3. And then depending on whatever this element is, I'm going to update my L at that position, right? So pick this element 3 and update the index 3 of L. That's all I have to do now. So let's do that then. So for score in scores, L of that so my L index 3 should be updated. And the way I'm going to get index 3 is by doing score 0, right? Because what is score having? Score is having this tuple, right? So when I say score 0, it's going to pick this element 3 and update it like plus equals 1, and do the same for score 1, because in my like loop, in my for loop, it's going to pick that tuple. So I have to update both the elements. So that's what I'm doing here. Score, and if there is like a confusion, like please feel free to stop me. I can like repeat what we're doing if this is like overwhelming. All right, that's it. That's all we have to do. Let's actually go and print L so that we understand what's going on. Okay, so that's that. Let's see if we get the right thing or not. Okay, so this is the list that is produced, right? And you can see there are 2 zeros. So the index at 0 is 2, right? It's 1, 2. And there are 3 ones. Let's see. Let's check. 1, 2, 3. And so that's why the index at position 1 is 3, and so on, right? Now our job is like really easy, but then there is a slight issue that we didn't think of earlier. So notice that the 4 is the highest number, which most likely is the mode, but now we have 2 modes. So just by doing a max and finding the index is not enough, because I'm just like going to get the index of the first element here, which is like 2, obviously. But now maybe the problem is asking me to get all modes. And so let me get all modes. So one way of doing that is get the max of this and get the indices of all those elements that has that max, right? So again, you might say, well, that's more work, again, another loop. But yeah, yes, we'll have to do that because this is like having 2 modes, right? So let me finish that. And if you have questions, we can walk through the code again. So that's not a big deal at all. As I said, I'm saving the max in my element most. Why? Because I just figured that we can have like more than one mode in that list. And also because this most can be 1, and there could be like many of those. So if like there is just one occurrence of one element, then we have to say that this list does not have a mode. And we did not think about that corner case as well when we were designing our solution. What happens if every number occurs just once, right? So let's include that now. So if most equals 1, this could be a possibility. Then you'll have to say print no mode. At least like statistically speaking, this is what it's considered. Or maybe you can have another message saying all the like none of the numbers appears more than once. All right. So else, if we found that most is not 1, right? Then just like go and loop through that like L and check the index. If that index, if like there's this 4 more than once, then like get all of them and put them in a list maybe, right? Or print them multiple times. Either way is fine. So for index in range length L, right? I think if L index, if that element exactly equals most, then I need that element, obviously, right? And so just print mode is, or put that index in a list and then print that list. Either ways, it's fine. Again, depends on what exactly the problem is asking you to do, right? Print that, and I think that's it, right? So let's try executing this and see what it prints. So this is what we wanted, right? We need to print all the modes. So mode is 2 and mode is 29. Why? Because 2 occurs 4 times, 29 occurs 4 times. All right. So this is like one way of getting the mode out of a list of tuples. Let's take questions first, and then we'll talk about the second method. Lauren, okay, Lauren, that's fine. This is like you're bound to be confused with this entire thing. So I can repeat that. That's not a big deal. So the solution approach here is that I'm going to extract all the elements. First of all, I'm going to get like which is the max element from this list, right? So the max is 30. And I'm going to create this empty list of all zeros of size 30, like starting from 0 up to 30, like so basically all zeros up to 31, if we are counting from 1. But because we are counting from 0, so I had like 0 to 30. So this is exactly what I did here. So I created this list, this empty list. And why did I do that? That's because I'm going to map the indices of this list. For example, the index of the first element is 0. So I'll go to my scores list of tuples and see whenever I see a 0, update this 0 index. So I'll see this 0 once, 0 twice, and so I'm going to update this element. Next, the index of this element is 1. So whenever I see 1 in my scores list, I'm going to update this index and so on, right? So that is exactly what I'm doing here. Whenever you see an element, for example, when you see 3, go and update the index 3 with +1. Because you saw it once, right? Similarly here, when you see element 2, go and update the index 2, which is 0, 1, 2 here once because you saw it once. And then print that list, which we got here. So you can see there are 2 zeros, 3 ones, 4 twos, because the occurrence is mapped to the index, right? And then we figured that like the max, which is the mode, obviously, occurs 2 times, right? 29 and 2. And so that's why I had to write this like extra code to extract like all the modes because we didn't think about it earlier. All right. Caesar, yeah, thank you. Yeah, this is efficient, of course, because you can map like the index to the, and this is like one solution approach, of course, dependent on the number of values that are there, right? Again, the drawbacks are if we had negative values, what to do. If we had huge number of like the actual values are huge, then you cannot like exactly map to the index. Harun, your question is, can we use the module statistics? I don't think you're allowed to use the module statistics because that's the whole point of this course, to understand how you'll do these problems from scratch. Kiran, your question is, could you go over the first loop? The first loop. This one? Yeah, sure. So this loop says for score in scores, that means pick up a tuple in scores, right? And check the first element because score 0 is going to be the first element. So if the first element is greater than high, then update this element high. Otherwise, if like the second element is greater than high, and this is my initialization, that's it, then update high. And I think we've done this kind of structure before where you initialize it with the first element and then keep updating depending on whenever you find a higher value. Lenny, your question is, how come you only do score 0 and score 1? All right, can you guys hear me? Okay, I'm so sorry about that. There was like some kind of internet blackout and like everything was gone. But yeah, I'm back now. Let me start sharing. All right, so we were discussing this problem here, and I remember I was answering this question of whether we are updating score 0 and score 1, and yes, we are. So essentially what we're doing is like going into every element, which is a tuple, and then picking the first element and the second element and updating the index of L. All right, if there aren't any other questions for this method, we can move on to the second method. And I'm sorry about the internet issue. I have no clue why it happened at this point. Uh, and my like the previous chat messages are not visible to me. So if you have like questions, you will have to type them again. Okay, great. So the second method, like the second variation for this problem that we're looking at, is that I will like keep track of all the elements in such a way that I'm going to or let me draw that, right? So let me draw this. What I'm thinking is, because I have like the scores list. So what I can do is I can create a new list somehow and keep a count of like groups of like groups that are built up. For example, I have like this group of, let's say, zeros, right? So 0, 0, 0, whatever number of times they occur, and then 1, 1, 1, whatever number of times they occur, and so on, right? So I'll have the occurrence of every element some number of times. So I'm only bothered when this occurrence changes. For example, 0 changes to 1. So I can keep like some variable that keeps a track of the count of these elements until they're not changing, right? So my count is 3 here, right? And let's say there is like some element, let's say I'm calling it previous count, okay? Whenever the change from 0 to 1 happens, so I'll see this element is not equal to this element, then update this previous count and give it the value of count, right? So the previous count is 3, and then start updating count with the count of ones. So now my count is going to be 4, right? So once I have the count equals 4, and I see that this 4 is greater than like my previous count, so basically my count is greater than my previous count, right? The moment this happens, what I'm going to do is I'll maintain another list wherein I'll put this element 1. Okay. And in this list, I'll keep track of the occurrence of every element. Whenever like the occurrence exceeds the previous count, then I'm going to update this. But also I have to keep track of the situation when count is equal to my previous count. Then in that case, I have to like keep both of them. So maybe append to this list. Then I have to keep track of both of them because, for example, in our example, we'll have this situation when 2 and 29, the count of 2 and 29 comes in, because both of them will be 4. And so I cannot get rid of that, right? And the good thing about this solution is that I don't need to keep a count of every element. The moment I find like a bigger count, then only I update this count element. Otherwise, I just like keep counting and I keep updating my elements. All right, so let's look at the solution and let me start writing it here. Let's try to implement that. All right, so the way I'm beginning with this is like to make it more convenient. I'm going to like extract, and let me get the scores list first. I'm going to change something about my input. Okay, so what is that? What exactly is that? What I'm going to change about my input is that I'm going to get all the elements and sort them. Because we just saw that the solution approach is to have those like number of elements like in certain ways, and it would be like really convenient if we begin from 0 and go up to the end. So how about we have these elements already in a sorted list and then just like keep counting them, right? And keep checking whenever a change occurs, update the count, update the elements, and go from there. How about doing that? So that's another way of thinking about this problem, which is, let me create this list, this empty list and have those sorted elements in there. So for that, for score in scores, this is simple. All I'm doing is like L dot append. And what do I want to append? Score 1 and score 0 and score 1, right? So score 0 and again L dot append, essentially extracting the elements from my list of tuples. And that's it. Come out and just do an L dot sort. Okay, let's see what this gives us. Okay, let's see what L looks like. Right, so this is the kind of input that we were talking about, right? So all I have to do is I have like these sorted. All I have to do is like keep track of these elements and whenever the change happens, because whenever the change happens, I'm going to update the count of this versus this and keep a track of the count. For example, I'll get a count of 4 here for 2s, right? And so the moment I get that, I'll keep it and keep comparing with the occurrence of the rest of the elements. And also keep in mind that this might come equal to something else. For example, 29 will be equal to this. So that's when this is going to be important. All right, so we know that this is our input and let's begin. So what I'm going to do is I'm going to create 4 variables and 1 list. That list is going to have all the modes in it. And so let me begin with the list. Whenever I find a mode, just like put it in there, which means I'll have the 2 and the 29 in there. And the rest of the elements that I'm thinking about is like, what is the max count for the current element and what is that element and the index of that. Similar to that, what is the previous element, like from the previous grouping and the value for that and the count for that. So then I need 4 elements, right? So current equals 0. All this is just like initialization. The important part comes in when we update them in the loop, right? Index equals 0. Beginning from the first, like the current is the first element, which is 0, obviously, and the index of that is also 0. So this is initialization. Previous, there is no previous element right now, so let's begin with -1, right? No harm in doing that. And count, as I said, count is going to like count for the current grouping and then get updated depending on if we find a bigger one. All right, so those are all the initializations. Now let's move on to the actual code. Okay. So I'm using a while loop and this index is the element for the while loop because I can access the element at the first like index, which is 0, obviously. And so the element is 0 and then update it, keep updating it, right? So I'm using a while loop for this one. While index is less than len of L, all right? And okay, so what exactly, there are 2 things that can happen, right? Either the next element is the same as the previous one, right? And so all we have to do is like keep updating count then. Okay, so if we'll have something, I'm not talking about that yet, else, because if we'll have like some kind of a more, I would say, involved kind of a structure. So let's like leave it like that. So in my if, I'm going to capture that the next element is not the same, right? I'm putting the easier part in my else. I'm saying the next element is the same, right? And so all I have to do is just like go and update my count, right? So that's what I'm going to do here. And count will be initialized up there. That's already initialized, I mean, count plus equals 1, right? And then come out of this for the while, just update my index so that I don't forget. Of course, like for every iteration, I have to check that. Now this if is important. Why? Because if the next element is different, and when it's different, then I'll have to check if the count of the previous one is greater than the current. So, and also have to keep account of like whether the count of the previous is equal to the current. And then based on that, I'll have to either create a new list with previous elements, or if not, just like append it to the list. So that's why this if is important. So the first thing I'm checking is that this L index, right, not equals, right? If this element is not equal to the previous one, right? Then again, 2 things can happen. Like either the count is greater than the current or the count is equal to the current, as I said. If it's greater than, then like our life is easier because all I have to do is just like go and update the modes list with this, whatever this element is. But if not, then I'll have to go and append, right? Either way, it's fine. So I'm capturing again in another if and else block. If you have a better way of capturing this, like with an and or something, please go ahead and do that, right? But I find it easier to kind of go and break it down. So I'm going to do if count is greater than current. And again, I'm going to repeat, like walk through this if this is not like 100% clear. So if I found that the count of my current one is, sorry, if the previous one is greater than the current, then that means I have to put that previous element in my modes list, right? And so just like go and put only that because I don't need the previous one. So just like go and create a new list, right? And this is one way of creating a new list with that previous element. And my current needs to be updated with my count because this is the max that I have. All right. However, if this is not the case, there could be this case of when they are equal, and I'm specifically capturing that because I'm not interested in any other situation. I'm interested in like when count is greater than current or count is equal to current. Otherwise, I'm not interested in this, right? So if my count is equal to current, because then also that's a mode. So I cannot just like get rid of that. So in that case, what I'll do is I'm going to do a modes.append previous. Modes.append and previous. All right, I think this is this, but yeah, in like if none of them, like despite all of this, like if we went into the if and the elif, I have to do something to my previous and my count, right? In the else, we said, I'm just updating the count because I did not find a new element, but now found a new element. And so I'll have to do something with like my count initialization. Otherwise it'll stay 0 forever, right? And so my count is 1 because I just like, I'm starting again. And my previous is the element itself, right? So my previous, regardless of the if and the else, right? L index and my count equals 1. If I'm in this like loop, then only. Otherwise, I don't have to do anything. Otherwise, I'll like my count plus 1 equals 1 and my index is going to change, right? And let's see what this prints first of all. And if it doesn't give us what we are trying to do, we'll have to like change the code and do things there. So print modes. Okay, let me quickly scan through this. Okay, so if my previous started with -1 and this they weren't equal, then this is going to get updated, which is okay. And then count is going to get updated with 1. All right, let's see if this works. We already have L sorted, so I'm going to execute this part. All right, so it gives us 2 and 29, which was expected. Why? Because it must have like encountered this elif at a certain point where we could just like go and append the next element that was exactly equal. So although this was a more straightforward technique in the sense that we just got all the elements, sorted them, and then kept scanning through them, like through the sorted list and checking the change of elements everywhere. But I think like this is the first solution actually that comes to anybody's mind. But I think the previous one was more elegant in the sense that we could map like the occurrence of every element to the index, right? So either ways, either one of them works fine. And then in this one, the issue that might come up is that like we have these like so many ifs and elif conditions, which weren't there in the earlier solution. And so we might get lost somewhere here, what to update and when to update. And as you can tell, just like by looking at it, even I had to like go over multiple times to make sure that we are updating everything at the right place, right? So these are like two different solutions to the same problem. And why are we looking at like these two different variations of the same problem? Because it depends on what kind of input you have. It depends on what is required from you in terms of like the output. And so let's say if the required output was some kind of a list, then this is a good solution. And let's say if the required output is that we shouldn't like exceed certain like limits of my data structure, for example, the list, then this is like a good solution. For example, if there was a 3000 here, but then the size of the list that will be created would not be huge. But if there was a 3000 in this solution, like the first one that we looked at, then I'm unnecessarily creating this huge list of values where there are all zeros and then there is that one 3000 at the end, right? So it again depends on what exactly we are trying to achieve. For instance, in this case, we are trying to like just get the mode and like not exceed like the size of the input itself, right? If you think about it, the L dot sort is exactly like if we look at L, for example. L is the size of the scores if we just like count them. It's just that they are like put in a different form. And by the way, like coming back to this dot sort and sorted, dot sort and sorted are like two important, I would say, essential techniques when working on problems like these. They really help a lot because you can actually organize your data in a certain way that helps solve problems. So whenever you're working with lists, whenever you have like some kind of a statistical problem at hand, for example, this one, dot sort and sorted usually come in handy. So try to like kind of frame your solution around that. Sometimes it's really helpful, as is the case in this one. All right. So as I said, today's lecture is going to be short. We just wanted to look at two different solution approaches to the same problem and get the same result, of course. And finally, like before we end, this modes is a list of like two elements. Depending on what the problem is asking you to do, you can access these elements and then print them in a certain way. And I have posted this code on the course website as always, so you can go in and have a look there. And this lecture was more in order to like make you familiar with these different techniques using what we already know. And from here on, we are going to look at some more data structures. For example, from Monday onwards, we are beginning with sets. There are a different type of data structure in Python, and then move on to dictionaries. And then we'll see compared to lists how efficient those are. But regardless, like although we look at more efficient data structures, there are some problems that cannot be solved by those. And so lists will stay with us till the end. This is a very powerful data structure, I would say. This provides us so much flexibility, and so in most problems you will require them. But sometimes we can get rid of like some of the efficiency issues that like lists offer. So for today's lecture, that's it from my end. If you don't have any questions, you are free to leave, and there are no lecture exercises for today's lecture as well. So that's it from my end. Thank you so much for joining. If you have questions, you can stay back. Otherwise, yeah. Harun, your question, I'm sorry, I didn't see that. Your question is, can you explain previous equals -1? So with previous, I'm trying to keep track of what was the previous element, and whenever a change occurs, then I go and like update my count, right? So previous equals -1 is just the initialization, because like I'm beginning, my current is going to be 0. I'm beginning at 0, so there is no previous. And so that's why I have a previous equals -1.